Hello and welcome to day 2 of the quadratic formula. We are on page 10 of your notes packet, and we are going to take a look at the bottom 4 examples on page 10, and after that we are going to move on to page 11, the first 2 problems. So for right now I'm scrolling back up to number 1 on page 10, and if you notice up here in the directions it says it's important to note or to know that the solutions of quadratic equations are not always integers. What that means is when we solve something, see how we have a formula, or we have an equation here, and it has an equal sign, that means we're going to be solving essentially for what x equals. So our answer is not always going to be a number. An integer is a number, and that's okay. We don't always have to get integers. So hang tight with me. We're going to go through these 4 examples, and then I will follow it up with a second video for the bottom 2 problems just below this. Well, actually, they're on the next page. All right. So we are going to start with our little heading here. We're on page 10 of our notes packet. Now you guys may have already printed it out, or maybe you're taking notes on a separate page, or maybe you're just practicing the problems in a spiral just like how I am. So no matter how you're doing it, I'm just going to walk you through these first 4 problems. So for number 1, I think the important thing to know is that it's always good to write out your equation for the quadratic formula. When we're solving for each of the different equations, especially like numbers 1, 2, 3, and 4, it's always good to have your quadratic formula written down somewhere. So I'm going to write that down. I always think of the song, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When I was in high school, my math teacher, Mr. Helmick, actually had a competition to see who could say that the fastest. So I dare you to try and say that 10 times fast. Yeah, crazy tongue twister, let me tell you. All right, so for number 1, our original problem is going to be 3x squared plus 5x minus 12 equals 0. All right. So what I'm going to do is I'm going to first identify what my values of a, b, and c are. So this is in standard form, so I can circle my 3 and say that that's my a. My 5 is my value of b, and negative 12 is my value of c. So what I'm going to do is I'm going to take those values of a, b, and c that I've circled and identified here, and I'm going to plug those into the quadratic formula where it has b, a, and c. Okay, so if we do that, we write x equals, now it says negative b, so I could do one of 2 things. For this example, I'm going to show you, here's my negative, and my value of b is 5. All right, so you can either look at it as, what is the opposite of b? What's the opposite of a positive 5? It's a negative 5. Or you can take the value of b and put it into parentheses here and have that negative sign outside of it. So I always do it like this, so that way I don't forget that there's that negative there. Negative b plus or minus, we've got the square root of b squared. So I'm looking at my quadratic formula up here. I need to find b squared. So I'm going to take 5 and square it. B squared minus 4 times a. Our value of a is 3. A times c, and our value of c is negative 12. Gotta extend that square root symbol all the way out. All over 2 times a. All right, so now from here all we have to do is simplify. So I've got x equals negative 5, and like I said, you can either think of it as what's the opposite of b, because it says negative b. The opposite of b, the opposite of positive 5, is a negative 5, or you can show your step here like I did. X equals negative b plus or minus the square root of b squared. So b squared, that's 5 to the second power. 5 times 5 is 25. Minus 4ac all over 2a. So what I'm going to do now is I'm going to take my values of -4 and I'm going to multiply it by 3. So I get -12 times another -12 divided by 2 times a, and our a was 3. I guess we could just write that like that. We know it'll be 6. I'll do that in the next step. I'll kind of simplify that part there. X equals -b, which is -5, plus or minus. Now here's the thing that I want to keep in mind. We could take the square root of 25, but then I also have -12 times -12. Two negatives equal a positive, and 12 times 12 is 144. So we could write that as, goodness, what did I do on my page? Oh no, okay. So if I have 144 and I add 25, then I would get what? 169? Square root of 169. And then I'm going to take this part, x equals -5 plus or minus. Sorry about that, guys. I thought I screwed up. And then we are going to take that and divide it by our 6, because that whole thing is over the 2 times 3. And 2 times 3 equals 6. And then we've got the square root of 169. And I believe, off the top of my head, I believe that that is 13. I'm just going to double check it on my handy dandy calculator here. And I'm going to do 13 times 13. And I got 169. Yes, perfect. Okay, that's what I thought. So now I have x equals -5 plus or minus the square root. This breaks up into 13 times 13. Two numbers that are the same. When we have two numbers that are the same, they're going to cancel out and move to the outside. All right, divided by 6. So now I have x equals -5 plus or minus 13 divided by 6. So I have to take, there's two different ways you could look at this. So you could either do x equals -5 plus 13 divided by 6, or -5 minus 13 divided by 6. And when I write out my problem, I want this part up here to be in the simplest form. So I'm going to go ahead and break that up into my two parts. I'm going to do x equals -5 plus 13 divided by 6. And I'm going to have x equals -5 plus 13 divided by 6. So over here, I did two pluses. That's what happens when you're making a movie and watching at the same time. So I'm going to have at least one plus and one minus. Okay, so then if I have a -13 and -5 more, that gives me a total of -18 divided by 6. And then over here, I have a -5 and a positive 13. So actually, over here we have x equals -18 divided by 6. We're going to simplify that in just a second. Over here I have x equals, 8? 13 minus 5, that should be 8. 13, 14, 13, 12, 11, 10, 9, 8. Divided by 6. And then I'm going to cut this one in half. It gives me 9. Cut this one in half, and it gives me 3. We can still reduce this one. And remember, 9 is the same thing as 3 times 3. And 3 is the same as 3 times 1. Two things that are the same, those cancel out. We're left with x equals 3 over 1. 3 divided by 1 is just 3. So there's one of our answers. I know it looks like a ton of work. Not that tricky. I promise you I'm just writing it bigger than the space it really needs, so don't freak out. You're like, oh my gosh, that's so much work. There's a lot of different steps that you can include together, but I'm writing out each and every step as I'm able to, and that way I can show you how I'm doing each of these different steps. So over here I crossed out 8 and I divided it by 2. I cut it in half and I got 4, and I cut 6 in half and I got 3. I got 4 over 3. You might be like, oh, was it an irrational number? Or no, it's like a top-heavy number, like an irrational fraction. So it's fine. Don't even worry about it that the top number is bigger than the bottom number. Not a big deal. We're going to move right ahead to problem number 2. All right. So number 2, we have 10x squared minus 5x equals 25. All right, so the main thing here for this problem for number 2 is we need to get it to say equals 0. So I'm going to subtract 25 on both sides. That goes away, and I'm left with my 0. And then over here, my 10x squared stays the same, because this has x squared, this one has an x, this one has just a number. So these guys stay the same. Okay, so first thing I did here was I got it to say equals 0. Now I can take my values of a, b, and c and plug them into the quadratic equation. So I have x equals negative b, and my value of b is a negative 5. So here's the perfect example of why I would want to put parentheses around it versus not. Okay, so here 2 negatives equal a positive. Here it just has 1, so we end up with a negative 5. Over here we're going to have a positive 5 when we write out our next step. So I've got this, x equals negative b plus or minus the square root of b squared. And our value of b is negative. So I'm going to put it in parentheses, b squared minus 4 times our value of a, which is 10. That's our value of a times c, and our c is a value of negative 25. So now I just need to divide by 2 times a, which is a 10. So I just plug that in there. If you needed to rewrite this first and then plug it in, you can do that also. Yeah, I'll probably do that for the next problem. So now I just need to simplify. X equals 2 negatives equal a positive, so I'm going to have a positive 5, plus or minus the square root of negative 5 times negative 5. So that's negative 5 times negative 5 minus 4 times 10 is, I always do these numbers first after I do my b squared. And I've got 40 times negative 25. All right, we're going to divide that by, and you might be saying, well, can't I just put like positive 25 here? Absolutely you can. So negative 5 squared is the same thing as a positive 25. So if I take that positive 25, I can write it here. In my next step, on the bottom, I did 2 times 10, which gave me 20. And now I'm just going to simplify. The reason I wrote that out is so that you remember that there's 2 of them. 2 negatives equal a positive, so we've got 25 minus 40 times negative 25. Two negatives equal a positive. So I have negative 40 here and negative 25 here. Two negatives equal positive. 40 times 25 is 1,000. And we're going to divide that by 20. And if I do this here, oh, you know what? Two negatives equal a positive. That should say plus. I've got x equals 5 plus or minus the square root of 1,025 divided by 20. And what I'm going to do now is for the 1,025, I'm going to draw a factor tree. Okay, so hang with me for just a moment, and we are going to make a factor tree really quick. All right, so 1,025, that actually, I'm just going to kind of tell you about this. That, just like up here, is the same thing as 25 times 1,000. So we're going to do 25 times 1,000, and 25 is the same as 5 times 5, and 1,000 is the same as 10 times 100. Yep, 100. Is my eraser dead on this? Yes. 10 times 100, and 100 breaks up into 10 times 10, so I have a 10, and a 10, and a 10, and a 5, and a 5. Now you might be like, wait, why didn't you break up the 10s further? Well, I definitely could have, but I already see that I've got two pairs, so just watch and wait and see. Okay? All right, so I'm going to put x equals 5 plus or minus the square root of 5 times 5. Those guys are done. Times 10 times 10 times 10. All right. So if you can notice right away that you have at least two numbers that are the same, you don't have to break them up further. So I've got two 5s. Those are the same. It's going to bump outside of my square root. Whoop, we got to divide this whole thing by 2 times a, which is 20. All right, so now I have x equals 5 plus or minus, ooh, I've also got a 10 out here. So I'm going to put my 5, because I crossed out the 5, so that's outside of the square root. Pair of 10s, that's going to move outside. And I've got 10 times 5 is 50. And left under the square root is my number 10 divided by 20. Okay, so now this problem is a little bit different than over here, what we had over here, okay? So what I need you to remember, biggest thing you need to remember at the very, 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 very end of your problem, you have to look at this number, and this number. All three of those numbers need to be able to reduce by the same number, otherwise you cannot do it. All three of those numbers have to divide by the same number. So